Hi guys, this is 4.5 notes, the last section of topic 4, solving rational expressions. So to solve these, we're going to follow these 7 steps. So the first step would be to factor out the numerator and denominator. Or if you're able to. Okay. The second one is find the LCD of all denominators. Okay, so if we follow that, we know that LCD of A needs to be x plus 4. So we need to multiply the numerator and denominator by x plus 4 here. Now, we multiply, like I said, the numerator and denominator of each term by the missing parts of LCD. Meaning, if the left side, the LCD is x plus 4, it's not missing anything, so we don't need to multiply. Right, but the right side's missing the whole x plus 4 in the denominator, so you need to multiply the numerator and denominator by it. Now, we're going to cancel any factors. And then we're going to get, we can't cancel any factors. We're going to get rid, so this step is big, get rid of the denominators. Okay, so, we're only going to set this equation up as 1 equals 2 times x plus 4. The denominators are the same, so we don't need them to solve for x. Okay. Then, we're going to simplify and solve for the variable. So we get 1 equals, I need to distribute the 2, so 2x plus 8. Then I need a minus 8 over. We get negative 7 equals 2x, divide by 2, and x equals negative 7 halves. Okay. So let's solve the next one, The next one, again, it's missing x minus 3. But now we set just the numerators equal to each other. You distribute this, you get 5x minus 15. Add 15 to the other side. We get 16 equals 5x, divide by 5. 16 over 5 equals x. All right, so why don't you try these ones on your own, A and B, and then so pause it, and then I'll show you the solutions. Okay, here's the solutions to them. Your LCD is x plus 5. Multiply the right side's numerator and denominator by x plus 5. Cancel out the denominator, and then solve for x. Same thing for B. All right. Here's a real-world example. You'll definitely see this on a quiz or an exam or something like that. So this is important to focus on. It says Arthur and Cheyenne can paint a wall in 6 hours working together. Cheyenne works twice as fast as Arthur. How long would it take Cheyenne to paint the wall if she was working alone? Okay, so let's let x equal the number of hours. And then let's look at Arthur. So Arthur, he paints one wall, in X amount of hours. So 1 over X of a wall in 1 hour. right? So, right, if he paints one wall in X amount of hours, for each hour, it's 1 over X. Okay. Now, Gianni, right, paints twice as fast. Twice as fast as Arthur. So, right, we just need to multiply that 1 over X, right, by 2. So 2 times 1 over X equals 2 over X, right? So she paints 2 over X of a wall in 1 hour. Okay. So, right, if it takes both of them together to paint a wall in 6 hours, right, that means, right, if we add the 1 over X, so for 6 hours, right, Arthur is 1 over X, right, that's A, plus Chiani, right, this is Arthur, Chiani, right, is 2 over X, would equal, right, 1 wall in 6 hours. So 1 over 6, right? X we said is number of hours. We're given the number of hours is 6. Okay. So now we just need to find a common denominator. So least common denominator, and then solve for our variable. Right. So right, the LCD here is 6x. Right. So I'll write in another color, right? This is missing a 6, so we multiply these by 6. This is also missing a 6 in the denominator, and this is missing, oh, not a 6, an x. Okay, so we multiply them out, and we get 6. Right, again, we're going to get rid of the denominator, so we get 6 plus 12 equals x, so 18 equals x. Right? We got rid of the denominators because it's just like we're solving from example 1, right? So x equals 18. So to figure out, right, we want to find out how long it takes Chiani to work alone. So c is equal to, remember, 2 over x. We just said 18 is x. So 2 over 18, which equals which equals 1/9, right? So 1/9 of the wall in 1 hour, right? So because the 2 over x was for 1 hour, right? So to do the full wall, right? Full wall is, right, 1/9 for 1 hour, so it is 9 hours, right? Because 2/9 would be 2 hours, so on and so forth, till you get to 9 hours to get the full wall by herself. Okay, and obviously, she goes twice as fast, so Arthur's would be 18 hours. All right, here's a try it on your own example. Very similar to the last problem. It says it takes 12 hours to fill a pool with 2 pipes, right? Where one of the pipes flows 3 times as fast as the other pipe. So, right, the faster pipe, right, would be 3 over x for 1 hour, and the slower one would just be 1 over x for 1 hour. Okay, so try that on your own. Pause this video, and I'll show you the solutions. All right, so we look, right, the slower one is 1 over x, the faster one's 3 over x because it's 3 times faster, and then, right, it takes 12 hours, so 1 over the amount of hours is 1 over 12. Right, so you solve for x, and you get 48, so it takes 48 hours for the slower pipe, right, because it'd be 1 over 48 of the pool is filled per hour for the slower guy, for slow, right? So it takes 48 total hours to fill that pool. All right, so let's look at some problems where we have to solve as well as finding extraneous solutions. All right, so first you need to still find your LCD. Right, so your LCD. Well, let's factor this bottom one to see. Most likely it's going to be x minus 5, x minus 3, right, which works, yes. So our LCD is x minus 5 times x minus 3. We don't need to multiply the first one by anything. We need to multiply this one by x minus 3, this one by x minus 5. All right, so we get x minus 3 for the first one, right, because it's multiplied by 1. And then we get plus, you need to multiply x minus 5 times x. So x squared minus 5x is equal to 2, right? Because we didn't need to multiply anything over here. We had x minus 5 times x is x squared minus 5. X minus 3 times 1 is just x minus 3. So then we get x squared. Let's get everything on the left side. What we get minus 5x plus x is minus 4x. And then we need to minus the 2 over. So we negative 3 minus 2 is negative 5. It's equal to 0. Then we're able to factor. So we can factor x minus 5 times x plus 1. So we get x is equal to 5 comma negative 1. And we need to find the extraneous solution. So x cannot equal, right, 5 and negative 1. Oh, sorry, 5 and 3. So, right, we cannot use 5 here. So x is just equal to 1. Because 5 would make us an extraneous solution, right? We cannot have 5 in the denominator. So x cannot equal 5. All right, so let's go through 2 more of these problems, right? So the LCD here is just x minus 2. So we just need to multiply the 7 by x minus 2. So we bring down the 5x. We get 7x minus 14 from that x minus 2 times 7. And then we get plus 10. And we can solve, right? So I'm going to move the 7x over. We get negative 2x. And then we get negative 4 from negative 14 plus x. And divide by negative 2. So x equals 2. And then our extraneous solution, x cannot equal 2. Okay. And then the last one, right? So technically we don't have a solution for this one because, right, it can't equal 2. So I'm not sure exactly how MathXL grades this, but it might ask you for what x equals and then the extraneous solution, so then you know it's not a solution. But then the last one, so the LCD is x minus 3 times 4, right? So these ones we need to multiply by 4. And then this last one, x minus 3. So we get 4 times 3 is 12. Then 4 times x is 4x. And then we get minus x times x is x squared. And then x times negative 3 is negative 3x. So we get 12 equals 4x minus x squared plus 3x. Let's move everything over. We get 0 equals, actually, let's move it all to the left side so we get a positive x squared, right? So we get x squared, and then we had 4x and 3x, so negative 7x plus 12 equals 0. And then we factor them. So we get x minus 6. Oh, wait, no. That wouldn't work. We get x minus 4 times x minus 3 equal to 0. So x is equal to positive 4, positive 3. And our extraneous solutions, right, would be positive 3, right, because x minus 3. All right, so what I want you to do is try these ones on your own. Again, check for extraneous solutions. So just tell me which are the extraneous solutions after finding the solutions. Again, if they are the same, most of the time, I'm pretty sure they are always. Just leave x equals to that, and then just tell me the extraneous solutions as well. So I'll pause this, and I'll show you the solutions. All right, so here's the solutions. Find the LCD, right? Then you get rid of the denominator, multiply everything in the numerator by what it's missing from the LCD, right? And here's your solutions.